Hello and welcome to the second part of the introduction. Okay, so in all of mathematics, we will use this kind of expression, okay, where 10 is the base and x is the exponent. So is an express is expresses an exponent of the base 10 in each cases. For example, like this one, okay? The number which a base number is raised and indicates the number of places that the decimal point is moved to the right or left to produce the decimal number. Positive power of 10 decimal will move to the right like this, 10 to the power of 2. So what it means is it is 1 times 10 power 2, which is equal to 100, okay, where the decimal point is over here, okay, and then it will move backwards 2 times, 1 2, leaving with 2 zeros, okay, 1 2, leaving with 2 zeros. So 10 to the power of 2 is equal to 100, okay. So the negative power of 10 decimal will move to the left instead, okay. If this is 10 to the power of negative 2, from this decimal point it will go forward 2 times, 1 2, and the decimal point will leave it at there, equals to 0.01. So this is the prefix used when the quantities measures are very big values or very small values. So when there is tera in the name, it will have a factor of 12, 10 to the power of 12. Giga will have 10 to the power of 9. Mega will have 10 to the power of 6. Kilo is 10 to the power of 3. Hecto, 10 to the power of 2. Deca, this is the base, okay, 10 to the power of 1. Usually we won't use deca. Deci, 10 to the power of negative 1. Centi, 10 to the power of negative 2. Milli, 10 to the power of negative 3. Micro, 10 to the power of negative 6. Nano, 10 to the power of negative 9. And pico, 10 to the power of negative 12. The one we usually use in mathematics is micro, pico, milli, and kilo, and in some cases mega, okay. But in the topic in this semester, we will only use the one that I've mentioned just now. Okay, let's move to resistors, okay. Resistors is an opposition to the flow of current is called resistance, and the device or component used for this purpose is called a resistor, okay. So resistors may be connected to either way around. So it can be connected in either polarity, like it does not have the negative or positive polarity like battery or a diode. Okay, they are not damaged by heat when soldering. So you can use high heat to solder them. So you should not be worried. Resistance is measured in ohms. The symbol for ohm is omega. Okay, this is the resistor color code. Usually there are 4 bands, 1, 2, 3, and 4. Okay, how to calculate this is where you see these color codes, okay? In the first and second band, you will see it as digits, okay? You will see it as digits 0, 1, 2, 3 until 9, 0, 1, 2, 3 until 9. If there is a case where the resistor is 5 band, 1 2 3 4 5, the third one it will also be used as a whole number value 0 until 9. But in this case, we will only see the 4 band 1 2 3 4 over here. So the third band will go through the multiplier. So the black one will count as 1 until 1,000, 10,000, 100,000, 1,000,000. Okay. Rarely we'll see 1,000,000 in the multiplier. We'll usually see the orange color or the red color or the brown color. Okay. So if as you can see from this example here, the first band is green color. The green is denoted as 5. The second one is blue, and it is denoted as 6. And the third one is orange. It is denoted as 1000. So that will equate to 56,000 with the tolerance of gold 5%. Okay, so 6,000, and then we'll have the tolerance of 5%. Okay, the bottom example is a 5-band code. Okay, so the first band is yellow, denoted as 4. The second band is purple, denoted as 7. The third one is black, denoted as 0. And the fourth band is a red color, which is denoted as 100. So with this, it still counts as 47,000 because this is a 0. So we will write it as 4, 7, 0, 0, 0. So there are 3 zeros over there. So it still counts as 47,000. But if this is a different color, instead of being black, it is 6, for example, blue. You'll write it as 47.6 kilo ohms. Okay, so the first band gives the first digit, the second band gives the second digit, and the third band indicates the number of zeros. In rare cases, the fourth band used to show the tolerance, which is the gold, silver, or other colors. Usually in what we use in real life, it is gold or silver. Rarely will you see other colors over there. So resistor color code by using this formula. Yeah, it is what I have shown before. So the question gives red, red, yellow, silver. So the red gives the value 2, the red gives the value 2, the yellow is power of 4, 10 to the power of 4. So it is denoted as 220 kilo ohms with 10% tolerance. Silver is 10%. So how would we write resistors in the uh, drawings instead? Okay. So if it's denoted as 0.47, we will write it as R47, where R is the decimal point. Okay, this decimal point is R. So that's why when you see 3.3 ohms over here, we will write this 3R3 because R is the decimal number over here. Same goes for 47. The decimal number is the farthest right. So we will write it as 47R. 220 ohms, 220 R, 4.7 kilo ohms. We'll write it as 4K7. Okay, this only applies when there is a prefix over here, kilo, mega, or micro. So the decimal number, instead of R, we will write K instead. 68K, we'll write it as 68K. 4.7 mega, we'll write it as 4 mega 7. Okay. So the basic laws of circuit. Okay, we know that the following is a series. Okay, this is a series punya circuit. So here there are R1, R2, and any number of R over here. To calculate the value of resistance, you just add all of them if it's in series. Okay, R1 plus R2 plus R3 plus Rn and so on. We will get the total number of resistors. But for parallel circuits, as you can see, this is all set up as parallel. We will use this equation where 1 over R total or R equals to 1 over R1 plus 1 over R2 plus 1 over Rn, how many ever resistors there are. Okay, so you write this in a calculator, you will get the total value of resistors, okay, where 1 over x equal to 1 over R1 plus 1 over R2 plus 1 over R3. Shift solve equal, you will get R equal, okay. So the basic law of circuits over here. Here are the example. Okay, so you know that there is a law to calculate these equations. Okay. Tunggu sekejap. So yeah, let me show you something. Display capture. Okay. Okay, so instead of showing you this, I'll show you in this app. Okay, we have this diagram showing 6 volts. The current is equal to 2 amperes, but we do not have the resistance. There is an equation to find this, and the one we always use is V equal to I times with resistor. Okay, this will always be the equation. Okay, so we know that V is equal to 6 volt, and then the current is equal to 2 amperes. So the resistor is the one that we do not know. So by using mathematical laws, we move 2 to the other side. We will have 6 over 2 equals to R. 6 divide 2, now we will see resistor, we will get 3 ohms. So that is the answer for example number 1. How about example number 2? Here, they do not show the value of current. We have the value of voltage, we have the value of resistors. So, we still use the same equation, V equal to IR. We know that V is 100, and then I is equal to nothing. We do not know what the current is yet, but the R we already know, times with 50 ohms. So 50, we move to the other side, we will get 100 divided by 50 equals to current. So with that, we will get the answer 10 divided by 5, 2 amperes. So that is the value for current. So we still use the same equation, V equal I R. So what is that? That is Ohm's law. State that the voltage across the material is proportional to the current flow through its provided that the physical quantities are constant. So this is Ohm's law. So current is I, voltage is E or V, resistance is R. So the unit of measurement for current is ampere or A, voltage is for volts, or V, resistance is ohm or omega, the unit abbreviation. Okay. So voltage measured is in volts, symbolized by the letter E or V. The current measured in amps, symbolized by the letter I, and the resistance measured in ohm, symbolized by the letter R. Okay. Based to the circuit shown below, find the total current flowing in the circuits. All right. With that example, let me remove all this if I can. Yeah, surely. All right. Here it shows the circuit. Let me reduce the size a bit. Where we have 6 volt, 15 ohms, 20 ohms, and 25 ohms. So with this, we still use the equation V equal to I times R. But there are a lot of R over there. So what we need to do is to add up all of the resistors. So R is equal to R1 plus R2 plus R3, which is equal to 15 plus 20 plus 25. So 15 plus 35, we get 30, 40, 40 plus 20 equal to 60. We get 60 ohms total for R. Okay, now that we know the total value of resistor is 60, we have the value for volts. So we get 6 equal to current times 60. Okay, so 60 will move over there. We get 6 over 60 equal to I. By using calculator, you get I equals to 0.1 in amperes. Okay, so that is how you would search the answer for current. Okay, that is for example number 1. This example number 2. Let me reduce it a bit. Here we also use the same equation where V equal to IR. Okay, as you can see, all of our example use the exact same equation, V equal to IR. But now the circuit is in parallel circuit, where all of these value of resistors is in parallel. So to find the value of R over here, we use the equation 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R is equal to 1 over 24 plus 1 over 24 plus 1 over 24. Let me see if I brought my calculator. I don't think I do. So basically, this equation, since all of these denominator is in the same value, I just do it like this. 1 plus 1 plus 1 over 24, 1 over R. So we get 3 over 24 equal to R. Okay? 1 over R. Right, so 3 over 24. Let me think a bit. So it's 24 divided by 3. R equal to 8. Okay, so now we know that R equal to 8 ohms. All right. So we will go back to the first equation. V equal to IR. V is 12 volts equal to I times 8. We'll get I equal to 12 over 8. And current will equals to... Oh, it asks us to calculate the total resistance. So we do not need to find the current. But in case they need to find the value of current, we answer it like this lah. V equal to IR. So what we did was correct. So our answer is R equal to 8 ohms. So that is all for chapter 1. You need to understand that most of our equation in the circuit, we will use V equal to IR. And this might be a bit tricky, but you need to do it a lot lah for the total of resistors in a parallel circuit. So thank you for watching. See you guys in the next video.